Director of Marketing for Security, Telecom, and Data Center Businesses. We have a distinguished panel assembled today to address the changing landscape of hardware root of trust solution. As we navigate the world of cybersecurity, the threats are no longer in the shadows, but they are front and center. Every day we hear about a new expose or an attack, and it affects every aspect of our life. The stakes are getting higher, and the businesses across the globe are not just fighting off sophisticated attacks, but they are also now being subject to tight regulations that are being designed to keep us a step ahead of these threats. So these regulations are reshaping all our cybersecurity landscape. They are pushing companies to rethink their strategies, um, being forced to adopt ironclad security measures that could be expensive and time consuming. And regulations like CNSA 2.0, the Zero Trust Architecture regulations from CISA, ETSI, and ESA, they are forcing an evolution in the tried and trusted way of implementing security solutions. And in addition to these, legacy solutions changing, there is also an increasing demand for agility. As we are becoming more modular and open, we need to incorporate components from various vendors into these open systems. There is a very increasing need of standardized interfaces, and then that will apply to root of trust solutions as well, because those systems are also getting modular. So today, our panel will look at how this changing security landscape is forcing a change in the root of trust solutions. We see evolution in TPM. It's ubiquitous. Everybody has worked with it. It's almost on every system. And then we are now seeing evolution in terms of new root of trust solutions coming up like Caliptra. We are also seeing root of trust FPGAs moving center stage to provide agility in this ever-changing threat and regulatory landscape. So, welcome panel, and let's get into the discussion, but let's begin with introductions from our esteemed panelists. Eric, could you start us off?
Sure, thanks, Mamta. Hi, my name's Eric Sivertson, and I'm the Vice President of the Security Business here at Lattice, based in our Silicon Valley office along with Mamta. Hate to admit it, but over 30 years of experience in security space, having been an engineer, practicing and building systems for military intelligence, space, and commercial. And very much looking forward to this discussion today with all of you. I hand it off to Bart from Rambus and let Bart tell you about himself.
Hello, thank you, Eric. Thank you, Mamta. My name is Bart Stevens, and I'm representing Rambus in this panel. And my background is in implementing cryptography and implementing security in hardware constructs, ASICs, FPGAs, and over time, I've been able to help our customers accelerate pure play crypto, if you will. But like we all know, and we will learn today, that crypto is not security. So especially elevating cryptography to implementing security, that is where Rambus comes in and helps their customers. How about you, Stefano?
Hello, everybody. My name is Stefano Righi. I am a Senior Vice President for the Global and Security Group here at AMI. It is 25 years that I am with AMI, and I have 40 years of experience in firmware development. We are embracing security for a very long time. And in the last 5 years, we have also launched new products that are fully dedicated to enforce platform-level security. That is a very important aspect in order to have a holistic security view for any infrastructure.
Thank you, Stefano. Thank you, panelists. Welcome. And let's get into the discussion. So I mentioned about regulations coming up like CNSA 2.0, and then also from European Union, the Cyber Resiliency Act. Let's unpack these developments a little bit. Eric, could you start us off by sharing your thoughts on current security threats and how they are shaping the security solutions and prompting the release of these regulations?
Yeah, sure, Mamta. It's an interesting time in the world right now. I think what you will see is that we're really having a paradigm shift in security, where for almost 80 years we focused on what I call a citadel, castle, or fortress model, where getting inside of a data center or into a secure facility was very difficult, and there were no network connections. Everything was internal to that facility. So guns, guards, and gates were the mantra, if you will, for 80 years, since World War II. But with the advent of the internet and significant advances, particularly with communications and 5G telecom, we've really moved to a new world where there are no boundaries. There's no hard, boundary to where the cryptographic systems and secure systems are located. They're really ubiquitous and everywhere. And because of that, there's a lot more exposure and a lot more problems. So this has led to a lot of regulatory changes like you're talking about. The first one that I like to point out is cyber resilience. And this is really where you don't have a castle or fortress to defend the systems inside. Every system has to defend itself. And I know, Mamta, you're a big fan of zero trust. That's exactly the concept here. So there's a lot moving in that direction. And it's where also you'll find that different devices need to protect each other. If you look at the recent hack that came at DEF CON, really isn't a hack. It's a vulnerability that was exposed in AMD called Synclose. Some of the most precious parts of the AMD processors are now able to be exposed and very difficult to remove unless you have an Overwatch or a cyber resilience type of component that could look into the deep levels of the memory to realize that the device has been compromised. So devices need not only to protect themselves, but to have a network of zero trust between other components to look into each other. So cyber resilience is a really big thing that we're seeing continue to grow. The other thing that's happening, and again, I know, Mamta, this is near and dear to your heart, is post-quantum cryptography. So not only are we having a paradigm shift in how systems protect themselves, but the fundamental underpinning of the modern world, which is public key cryptography, your little lock on your browser, right? That's all what we call legacy public key cryptography. And now NIST just announced the new public key cryptography standards that will be post-quantum resistant. And so we're having a tremendous amount of change that's going to come from not only having devices go into more of a zero trust mode, but they're all going to have to start to use these new post-quantum algorithms, which are quite complicated. And so, this is a very interesting time, and it's one where there's a lot of change, both at a protection level and from a compliance level, because of these new regulations that are coming into play. And so, Mamta, I know PQC is like a real hot topic for you. Maybe you could share a little bit about what you see on the regulations coming from that.
Yeah, thanks, Eric. Yes, absolutely. In addition to the requirements for cyber resiliency, now we are seeing it is also being almost dictated, and it is becoming imperative with the advent of quantum computers that we see how we do cyber resiliency. We have to move away from our traditional asymmetric cryptography, because quantum computers can break that kind of cryptography like bullet to a paper, literally. You cannot increase key strengths and say, oh, now I move from 256 to 384 and I'm quantum computer safe. No, its bullet to a paper. So a new kind of math is needed, a new kind of way of doing things is needed, and that's where NIST stepped in and has been, asking and for submissions. And on 13th August, they announced the final version of 4 algorithms. Bart, was it 4 or 3? It was MLDSA, MLChem, Sphinx Plus,
And
and
yeah, Mamta, those were indeed the one that now are finally standardized. NIST
yes.
picked indeed a couple more, and actually they are still inviting the academic and industry community to come up with further methods, because we see that the lattice-based, no pun intended, but the lattice-based methodologies, the math behind it, seems to be quite attractive for implementing quantum safe crypto, as we like to call it. But what if in 5, 10 years that lattice-based methodology may not be that successful? So they're really asking us and the academic world, please come up with alternative methods. One is called Falcon, which is also selected. It's a bit of an odd duck, if you will, because it relies on floating point implementations, which are typically harder to implement in a secure, robust way. So that's why that particular fourth one has not seen a standard yet.
Yeah, no, thank you for supplementing that. And we are watching it with a lot of interest because we are in the area of providing solutions, and we will knit these algorithms into our future root of trust solutions. So the biggest driver for adoption of these algorithms, of course, there is that threat on the horizon for quantum computers. They will come, and a lot of people can naysay it, oh, it'll come in 2035 or 2040. People have different timelines. But CNSA 2.0, which is the commercial arm of NSA, they have actually taken a stand, and they have listed a timeline where servers or any kind of firmware signing must have these PQC algorithms as default and preferred by 2025. And for networking equipment, the default and preferred timeline is 2026. So that is right on the horizon, and that is now galvanizing the whole market to pick up these finalized algorithms and implement solutions. So this regulation, this threat, and finally NIST's release of these algorithm specs has really now ushered the urgent need for solutions in this space, and we will explore a little bit more. So, Bart, why don't you continue your chain of thought? Rambus is providing, IPs in this area. You guys are leading charge. Why don't you, tell our viewers about what's Rambus doing and how are these regulations influencing the development of new technologies and solutions in your space?
Thank you, Mamta. Yeah, exactly. So these new regulations that you mentioned, they are indeed a call to action for us in the tech industry. The Cyber Resilience Act emphasizes not defending against attacks, but also ensuring that these systems can recover quickly. This means we're not just creating barriers, we are also, like to call it, designing escape routes. At my company, we're integrating these principles into our security IPs that we make available for our customers. So ensuring they not only prevent, but can adapt and respond to threats dynamically. And I always like to see us as an IP provider be almost at the forefront of our, let's say, the defense mechanisms. Of course, we have the algorithm definitions, that's step one, but now we are called to action of providing robust implementations, having learned from the past that even, taking the spec sheets and following the algorithm steps, hey, okay, this is how you run the test vectors, this is how you implement, if you will, the function. But again, then we would be making the same mistake. How about the security? quantum safe crypto works with key materials. It's asymmetric. The one becomes public, the other one doesn't. These keys need to be stored somewhere. How can these keys be protected? That's where the root of trust functionality comes in. So we'll have the ability to build upon the capabilities of root of trust designs, of learning from mistakes in the past that the industry has implemented, say, the old mechanisms of RSA and elliptic curves, and then through side channel attacks still could open doors to the system by leaking information to power or EM. So that's where Rambus likes to come in and help our customers provide not only efficient implementations of algorithms, like for power performance area, if you will, but also keep the same level of robustness, having learned from the past.
Yeah, thank you. So I find it interesting that you mentioned two key vectors to keep in mind, like secure protection of the keys and protecting against side channel attacks. So our viewers have to keep that in mind, that when you implement a root of trust, even with new robust technology like a post-quantum crypto, these traditional ways of doing security don't change. Though these security-minded practices don't change, you still got to protect your keys, and you still need to watch out for side channel text. Yeah, thank you for that reminder. And then I'll come to Stefano now, and I am going to broaden this discussion a little bit. We are also looking, in addition to regulation coming our way, we are also looking at systems becoming more modular. And when systems become modular, that means we are picking pieces from various vendors. So they all need to interoperate, and hence we need open standards. So, and this is very evident in data center technologies. And OCP has been instrumental in shaping these open standards. So, Stefano, how is OCP looking at these new regulations and the broader need for cyber resiliency?
Thank you, Malcolm. Yes, modularity is surely the word of the day in OCP. We can hear composability everywhere. All the new standards coming out from OCP are all centered around modularity. And in this modularity, OCP is completely committed to enhance the cybersecurity resiliency across the board in every module. And OCP is a great environment in which global partners can collaborate together and align the new open hardware and firmware design in order to address all these needs coming from all these new worldwide regulations that are emerging. OCP is really fostering a great community that surely prioritizes security in every hardware and firmware design. And in this way, OCP is really setting new goals, new benchmark in order to achieve open, secure, and resilient infrastructure architecture for the future. One particular effort that I want to point out into the OCP world is the Caliptra project, which is surely a prime example that is aimed to standardize the root of trust, standardization that is necessary in order to improve secure solution in the moment in which we have this increasing fragmentation of multiple platform architecture coming together.
Thank you, Stefano. Yes. So now we have, our security discussion that we are having. So we have new regulations, we have threats, we have modular systems. We want to make systems more approachable, more easily maintainable, but then we have to keep knitting security back into it So the landscape becomes challenging, and collaboration and open standards will be key to still keep advancing our modularity and ease of use while keeping our security posture. So Eric, I'll come back to you, and now I would like to hear from you. How should businesses adapt, to these changing environments, threats, and regulations?
Yeah, it's a good question, Mamta. And building on what Bart and Stefano also stated, just to spell out OCP, O in OCP means open. I think open compute, OCP platform. So I think the concept of more open standards is critical to the future for businesses. So understanding these, participating in these organizations, because they are open, they will let anyone that has an interest to get involved. I think that is the future. Even if you look at the NIST process for post-quantum, it really was an open competition, if you will, for all the cryptographers. The open standard process brings more eyes on the problem. And so by having more review and more look onto a solution, usually it's going to be more robust and stronger versus a proprietary or private solution that doesn't interoperate and it doesn't have enough eyes on for the flaw. And then when the flaw is found, it can be at a very inopportune time, especially if your critical infrastructure relies on this. So I would say the number one thing is that more companies get involved in the open process, understand it, because I think it is the future. You see this with software, you see this everywhere. It's happening now with security. OCP is doing a good job of leading that charge. I think the other thing to watch, you mentioned, is CNSA, which is really going to drive now the post-quantum algorithms from NIST into critical infrastructure. So anyone building networking equipment, anyone building communication equipment, anyone building servers or critical compute capability is going to need to be CNSA compliant in order to sell into the US at a minimum. And we're seeing Europe look at this as well. And then speaking of Europe, we have the Cyber Resilience Act, which is also going to be a very critical factor for anyone trying to do business in Europe. They're going to have to be compliant. And that is where they can catch vulnerabilities with their system. And once they know they have an exploit or a problem, they have 24 hours in which they have to get that reported and then to be able to patch their equipment. So for companies that are trying to keep up with all this, which is a daunting challenge, you really need to get involved. I think it's critical that you can't sit on the sidelines. It's a much better process if you actively get involved in it, and then understand they're all open standards. It's easy to get access to this, to understand what the requirements are. And I'm going to put in a plug for FPGA technology. This is one of the places where FPGAs really shine. They're flexible hardware. You can unroll algorithms. You can do things in a massively parallel way that are not as easy to do with limited architectures like a microcontroller. So for many of these requirements, an FPGA is going to make it easy for you to implement those standards and be able to be compliant, as well as to be nimble or agile as they change or as exploits and issues come up, which is inevitable with all the complexity now that we're managing.
Thank you. Yeah, Bart, your thoughts on how businesses can leverage new technologies to comply and benefit from these regulations and stay ahead of the curve on the threats?
Yeah. So Eric brings a lot of good stuff on the table. So businesses should look towards integrating scalable and flexible security solutions, and the flexibility here is key, because we cannot expect that these acts and regulations are going to be stable. They will be dynamic. New threats will evolve. And what do you do if you carved everything in stone? Of course, crypto and security needs to go in hardware, needs to be agile, robust, and say the root of trust technology should be hardened in let's say ASIC technology. but having the flexibility of adapting to regulatory changes or technical changes if quantum computers become even more powerful, then you're stuck. Your current generation of your product might be stuck. You might be able to do some firmware updates, if you will, but say if we need to start adding new constructs or have basically span the life cycle or the lifetime of your device, then flexibility comes in. So a good founded architecture as a combination of hardware, firmware, and software, and soft logic and FPGAs, if you will, that could be the key combination for future-proofing your design, staying ahead of the curve, and allowing your customers to invest, say, today. And that investment is always problematic, if you will, because being in this industry for so long, I just cannot deny that security is still seen as an insurance policy. Nobody likes an insurance policy. We have to. So, how much do I pay? Why do we still see leaks out there? Why do we still see successful attacks? That's always the balance between how much am I going to spend, how much I'm going to spend in time making my design more robust and test it, or bring it to market now. And a good example is maybe going 15, 20 years back when ARM announced like Trust Zone. That was at that time revolutionary. And everybody said, okay, we're going to implement it. But history has shown that, dividing your software stack in a secure and normal world was hard to do. So people started releasing, let's say, beta versions running normal world only, and the beta versions became final versions. So, and that's where I believe that the regulations come in. Let's not allow the industry to find the escape routes to go the simple or cheap way, because it's hurting their business, it's hurting their customers' business, if you will. So I like the regulations, and I like the standardizations, because cooking up your homegrown, let's say, security solution or root of trust makes it hard for customers to start using it. So that's why the Caliptra is a tremendous good effort on standardizing this say root of trust for measurement ID. So that's what I will see that later, where Rambus also jumped on and making sure that our customers can use it.
Yeah, great. Thanks. And you gave the perfect segue for my next point, was this standardization of root of trust. And you made a very good point that this homegrown security, oh, I can do security myself. Why do I have to buy, pre-tested, validated security solutions and pay all that money for it? And I always sometimes, chuckle about it that, hey, security, implementing security is cheap and easy, but getting it right is really hard and long. So, getting validated solutions, standard solutions for security looks like to be the best way forward. And Caliptra is a very good example of standardization there. So, Stefano, why don't you introduce our viewers about what is Caliptra, its origins, the intent behind it, and what we are seeing happening in the open community?
Thank you, Mamta. Caliptra is very close to my heart, and I'm very glad to talk about this. Caliptra is currently spearheaded, is currently pushed by the CHIPS Alliance, even if it was incepted by the OCP Security Working Group. The goal of Caliptra is to address the need for a standardized open source root of trust implementation, root of trust for measurement. The specification, the Caliptra specification, are published by OCP, and you can access them through the OCP website. And but all the source code that is developed both for firmware and for the IP block are stored into the into the Chip Alliance repository. That is, Chips Alliance is part of Linux Foundation. So you will find all the source code for firmware IP block into the Chips Alliance GitHub. The overall security posture of every silicon design depends on establishing a core root of trust that stems a chain of trust. The root of trust and the chain of trust are responsible to attest the integrity of both the configuration and of the mutable code that is loaded from a flash device. So the role of Caliptra is to ensure that every component in the platform can be verified from integrity. So practically, Caliptra is able to provide measurement of the firmware. So the security is really starting from the firmware. And this is a basic tenet of that align with zero trust principle. In AMI, we say that zero trust really starts from a secure firmware, and we are pushing from that. Caliptra, as you indicated, is an open project with many contributors. Just to name a few of them, we have developers coming from AMD, NVIDIA, Google, Microsoft, and also from AMI.
Thank you, Stefano. And just for our viewers' benefit, I would like to define a few terms here. So we have mentioned zero trust architecture and root of trust of measurement and what happens there. So in the segments that I lead, data center and now networking as well, zero trust architecture is ubiquitous, and it's a big growing regulation as well, that hey, everything should be based on zero trust architecture, which means never trust, always verify. And verify what? So we can think in terms of a passport check and or a background check. So you are verifying that. So Caliptra, what it does is, as a root of trust of measurement, it will measure the firmware. It's an IP that goes into the SoC, and then for the SoC, the firmware that is running on SoC, Caliptra will take the measurement of the firmware, what either it could be a hash or it's a version number or whatever, and it reports up to the platform root of trust. And there it is verified, and then some action is taken on it.
Yep.
Either you go through or you don't go through. So it's almost like a passport check. Show me your papers, and then if the papers are right, you can pass through. So platform root of trust acts like a passport checker, and Caliptra in every SoC device acts like that passport provider, that here are my papers. And then every component can then have a standardized way of showing that they are running the right firmware and they are the expected component. So a lot of people sometimes I've seen get confused. What is Caliptra? Is it a firmware? It is an IP that will go into the SoC. It can be implemented in FPGA as well. It can be implemented as hardened device. So Bart, I would invite you to talk about Rambus's Caliptra implementations.
Yeah, thanks, Manta. So, and I really enjoyed your explanation because it hits the nail on the spot. So what we've seen at Rambus, indeed, that our customers immediately after the Caliptra announcement, say 3 years ago, started asking us, hey, this is open source. What is Rambus offering? What is the state of Caliptra? And once we started digesting Caliptra at Rambus, we've seen a lot of overlap between Caliptra and what Rambus was already doing on root of trust and measurement, if you will. But again, here the standardization comes in. So what we did and what we've seen that our customers really like is we combined Caliptra as a boot component of our root of trust foundation, which we call Crypto Manager, which is more than a root of trust for management, because once the systems have booted, you want to keep attesting the system, you want to keep doing measurements, but also you want to leverage whatever the root of trust offers as security services to the platform. And these could be, and we'll dive into that more, these could be, say, trusted platform module capabilities with secure boot, secure storage, again, the authentication of the hardware, and then also have data encryption. And having all those resources under a single roof, which is the Rambus root of trust, which still gives you the flexibility to augment to new mechanisms, to add quantum safe crypto, that our customers find the key to their security solutions.
Okay. Stefano, AMI and Lattice have been working on the Caliptra solution hand in hand. Like, can you explain and to our viewers, how is that collaboration working?
I mean, Marta, we are working together for more than 5 years at this point, and we have run already through. We are now starting the third generation of platform root of trust together.
Yeah.
And Caliptra obviously is something that we couldn't ignore at this point. And what we really wanted to do is to demonstrate that our platform root of trust is fully compatible with either a Caliptra-based root of trust or a legacy root of trust, because we know that our system will not turn around in just a second from the legacy solution to the Caliptra solution. So what we did together is to take an FPGA, instantiate into it the IP block that are coming from the Caliptra repository, and associate with it a simulation of an SoC, and connect this working sample with our standard platform root of trust based on Mac&X with our Tectagon firmware running into it. And we have demonstrated that in the same way as our joint solution is capable of measuring and testing legacy security system, is also able to communicate with a Caliptra-based system, take the measurement, and as you were saying, checking the passport that is providing a running picture, but also an identity of the SoC that is running with Caliptra. I'm talking about identity because identity is a subject that has been way too long ignored into hardware and platform development. And really with Caliptra now, identity is taking a primary stage, and it become absolutely, because the identity of the platform is as important as the identity of the user that are using our infrastructures.
Yes. And just to build on that, like a lot of people get confused that, if Caliptra comes, will the platform root of trust not needed? Would I? No. Caliptra will generate standard passports. If you were to extend the analogy, you always will need a platform level passport check who will check, which is, verify, and then take action, go or no go. So you need that whole architecture where Caliptra knits into the existing platform root of trust. So thank you. And I would like to circle back. Bart mentioned something about TPMs. And I in my introduction, because TPMs are always in front of my mind, they're always there on every platform. I would like to invite Eric to talk to us about the evolution in TPMs. That's another root of trust technology that is evolving. And what do we see in that crystal ball for TPM future?
Yeah, it's a good question, Mamta. What's the difference between TPM, Caliptra, and a cyber resilient root of trust? There's a lot of different ways to look at this. So the TPM Trusted Platform Module is probably one of the earliest standardized roots of trust that came onto the market. It's done by not an open group, but a industry group close to an open group. You can join and be a member. Lattice is a member. I'm the representative for Lattice at the Trusted Computing Group TPM work group session. And so that you find a lot of the same players that Stefano mentioned. Google, Microsoft, NVIDIA are all part of the Trusted Computing Group and helped form the TPM standard. TPM standard started in the mid 2000s, and the current version, TPM 2.0, was ratified in I think it was 2012 or 2014. And that was really one of the first true roots of trust, root of trust for measurement, but also for key storage, for key generation, all the critical things that you need cryptographically to do identity and to trust a system came from the TPM standard. But there are a couple of issues with the TPM. It's great for those things, but it wasn't an open standard, which is now what you're seeing with Caliptra. Caliptra very focused on that identity, Stefano, as you mentioned very well, to be able to, in a zero trust environment, how do I know who this thing is that I'm going to talk to, and then how do I trust it? And so some of the TPM capabilities are still also going to be used as well, particularly key storage. Caliptra gives you a methodology to do the attestation, but then where do you store all of your critical keys for features and functions of a system? The TPM typically comes in to give you that capability. And then layered on top, like I started earlier, is cyber resilience, where a system can do an overwatch and constantly look for attacks, something we didn't put a lot of time on in this discussion, but you really need all of these things. So if you look at a TPM, it was the godfather of this process, if you will. But now we're evolving further, and TPM will probably change too, because the original TPM standards are all focused on legacy public key, and now we need to bring in the new PQC capabilities. One last point on TPMs, Mamta. You are able to do them in a soft way and run a soft stack of a TPM. And again, I'm going to go back to one of the nice things about FPGA technology. We can run all of these. We can do Caliptra, we can do a soft stack of a TPM, and we can do cyber resilience, where we're doing continual overwatch, which is going to be very important to help with that EU cyber resilience compliance. And we can do the PQC algorithms. So to put in a bit of a plug for FPGA technology, it's a really good tool right now to help you be compliant and across all of these different standards that are now affecting our users.
Okay. So excellent discussion, and I think we got really engaged in that. And now the time clock is telling me we need to wrap this up. So this is to all panelists to sum up your takeaways for our viewers. With this increasing security threats, stringent regulations, how should we prepare for future of security challenges, especially in terms of hardware root of trust? Just briefly reflect on the future, their impact, the future of these technologies and their impact, and the business strategies that our viewers should take away from today's discussion. Eric, why don't you start us off?
Sure, Mamta, thanks. Yeah, just like I was saying, I think because there's a lot of changes happening in the market, you need to be agile to be able to implement each of these different requirements that are coming. I think we're blinded because we like FPGAs, but at the same time, FPGAs are a very good platform in which to be able to do all of these things. So I would highly encourage our users and the audience today to go take a look at FPGA technology, because it does give you an edge to be agile and implementing all of this. And with great partners like AMI and Rambus, and we have others, you can see that we have a very rich ecosystem to be able to take all the hard work that these companies have done in the security space and easily implement. So that would be my takeaway, and pass it back to Bart. Bart, tell us what you think.
Yeah, so indeed, so and hearing your history on TPM, I cannot help recalling that we might, the older ones of us might all remember how much pushback back then Intel got, like from putting a TPM on the motherboards, like, hey, everybody's going to spy on us. And look where we've come now. We all are screaming, we need something to identify the user, to identify the platform, to provide these security services, to make sure that we got this trust in a zero trust world, if you will. Rambus has taken all these inputs and combined this in their FPGA capable root of trust technology, quantum safe cryptography, side channel attack robustness. And if we all mix that into our platform root of trust module called Crypto Manager, and again, also I invite you to look at the Rambus website on root of trust designs. We can help customers get a robust design with a very short time to market, having let's say programmable examples of how to do attestation, how to do provisioning. So let's not forget that we all talked about the need for identity, but how do you establish that initial identity? That's provisioning. So Rambus also helps customers create the identity, either by having the chip self-provision and log into a booking system, or have a provisioning infrastructure, say in an untrusted fab, program that identity and then put it in the root of trust and providing these services. So I think the combination of FPGAs with Rambus technology is the best bet you have.
Stefano, your takeaways?
Sure. So as we have seen, we are moving from a legacy world that was really proprietary and monolithic, and we are moving to a modular systems. Now, there are not, in the old world, there are not standard configuration. It is very difficult to maintain the flexibility that is required into a modular system. So with the introduction of a modular hardware architecture, these standards are absolutely necessary and are evolving. And OCP is really giving us this game-changing, is giving us the steam required to move forward this constantly changing game. But there is one other point that I want to underline. OCP is also teaching us how to do these things, because I could say that OCP, with another initiative that got started last year, OCP Safe, is really giving us a guideline on how to ensure that these open architecture are really secure. I'm talking about the OCP Safe initiative. Caliptra has been one of the first projects that has been able to produce an OCP Safe short form report. What is a short form report? Is practically a validation provided by a third party, an independent third party, that the design and the implementation are sound and robust and are implemented according to modern security practices. And as we have spoken here in very depth, post-quantum algorithm will become center stage starting from next year. And also Caliptra is fully committed to include post-quantum algorithm into the Caliptra architecture that by definition is modular. So plugging in, replacing a CDSA with post-quantum signature will be something that will surely be achieved by that is already underway into the Caliptra world. And one other thing I think that Caliptra is teaching us that in order to achieve an industry alignment and having a consistency, it is necessary to have a minimalistic approach, and in this minimalistic approach, identify, make use of interfaces that are providing a foundation, the foundational security required in order to enable composability and orchestration into this modular design. So, as I said, identity is the new kid on the block. It is finally something that I was pushing for a long time into our design, and I finally see coming through. And we have already implemented this together, Lattice and AMI, since more than 2-3 years.
Yes.
And as you were saying, platform root of trust is not jeopardized. The need of platform root of trust is not going to be jeopardized by Caliptra, but will be enhanced by Caliptra, because only platform root of trust will provide update, recovery that are necessary to have a holistic security solution that protects the entire platform.
That is so true. And that is such a big confusion in the industry going on right now. And thank you for bringing up OCP Safe. We are going to actually do a security seminar just dedicated to OCP Safe, because I know it is getting really instrumental in driving discussions and implementations in our hyperscalers and all on all those architectures. So thank you, panelists, for your insightful contributions, and thank you for audience for joining us today. So let's together continue to push the boundaries of what's possible in cybersecurity. Really a pleasure to have you all with us. Thank you and goodbye.
Thank you.
Thank you
Thanks, everybody.
very much.